So here are more bonding questions from the 2017 Regents Exams. Pause the video, work on the questions, and then come on back and check the answers. I apologize again, the clarity is not very good here. I do have a website, nychemcoach.com, where I'm going to put up the PDF files for these things, and you can check that out and print that out, or at least work from that if you'd like. The key is, of course, to be working on questions and correcting those mistakes you made, and also seeing what questions are repeating themselves, or the types of questions, so you can really get yourself ready for the exam. Alright, so pause this, come on back, go through it. Okay, so let's take a look. For question 12, you're asked here, which property is used to determine the degree of polarity between two bonded atoms? The degree of polarity, it's called electronegativity. It's how much of a pull an atom has to pull an electron towards itself. So the element with the greatest electronegativity, of course, is fluorine. Now, if you take a look at question 17 across the way, it's an electronegativity question just asked in a different way. An atom of which element has the strongest attraction for electrons in a bond? So they're asking you about electronegativity without saying the word. Now, when you go through the choices, you have a couple of ways you can do this. If you take a look at the periodic table, again, fluorine is the most electronegative. Whatever's closest to fluorine is also going to be more electronegative than what's further away. And of the four choices, aluminum, let's see, aluminum, carbon, I got to go back because I can't remember, chlorine and lithium, I think it's pretty clear that chlorine is the answer. It's closest to fluorine. But if you want to make absolutely sure, the other thing that I want to remind you of is that electronegativity, all of the values are on reference table S. Alright, so let's go back. Let's look at 13. So we have a table here, and it says which statement classifies the two compounds. Well, that means that you have to know properties of different compounds based on their bonding. Look at the melting points. Melting point here is high. Melting point for number 2 is low. Boiling point is high for number 1, low for number 2. And then electrical conductivity, good as a liquid or an aqueous, that's ionic. That's a fact. You just need to know that. And poor as a liquid, it's got to be covalent. And covalently bonded substances, of course, are molecules. So the answer is number 3. Let's take a look at 14. Solid sample of a compound with a liquid sample of the same compound are each tested with electrical conductivity. Which test conclusion indicates that the compound is ionic? So again, you need to know that ionic compounds conduct electricity when they are a liquid or they're dissolved in water, right? So L or AQ. So it does not conduct electricity, or they do not, as just the solids. They have to be dissolved in water. So the answer is 4. The solid is a poor conductor and the liquid is a good conductor. The only group of solids that are good conductors, of course, are your metals. Okay, now 15. Which molecular formula is also an empirical formula? You have to know that empirical formula is the lowest whole number ratio, right? I can't reduce it anymore. So of the choices, the only one that can't be reduced further without either a fraction or a decimal is choice 4. Then we get to 16. Which type of formula shows an element symbol for each atom and a line for each bond? Well, if there's a line for each bond, it goes beyond being molecular. It would be structural, which is choice 2. Let's finish it up with the last 2 questions here. Which term represents the intermolecular force in a sample of water? Water has polar bonds and is a polar molecule. It has a negative end and it has a positive end. But because oxygen is so electronegative and hydrogen, of course, is only one proton, one electron, we have this very strong molecular polarity, which is known as hydrogen bonding. So anytime you're dealing with intermolecular forces in water, it's so strong, it's called hydrogen bonding. And finally, the last one, I added 19, right? Paper chromatography and separation. You might say, wait a minute, shouldn't that be with matter? And I guess it could be, but with chromatography and separating components of a mixture of dyes, here, I just kind of did this so you can't see it, so let's see. It's going to be based on differences due to molecular polarity. So that's why I had it here grouped with some bonding questions. Check out some more videos. The next video or next part of bonding here are going to be the short answer questions.